welcome everybody. So today I have the pleasure to show you what JMP is about and what this means for academic users. And this webinar is designed for professors in mind, teaching with data. But if you are not teaching, maybe not academic, or if you know JMP already, don't hang up. We will have some useful information for you as well. So during this hour we will spend most of the time with live demos of some JMP basics. So we will cover basic navigation in JMP, how to import data, some platforms for summarizing and graphing data. You will get some tips, especially for new users, and we will see some examples for basic analyses. I will also point you to some free academic resources before wrapping up at the end. So, welcome to JMP, which first version was released by SAS Institute in 1989. So after almost 3 decades, JMP is still very different. Graphing and analyzing data is more like a journey we call statistical discovery. On the one hand, and important in teaching, JMP is very easy to use. So this quote from Oxford confirms it very nicely, so that there are very few user issues because JMP is so easy to use. Second, free resources are available for self-learning and to solve any problems. And if a user is still stuck, so the SAS technical support is awesome. And on the other hand, and important for researchers, JMP has powerful tools built in. But there are no limits. You get all development tools for custom applications. You get a dashboard builder and a scripting language, JSL, JMP scripting language, which also integrates JMP with other packages, including R, MATLAB, and Python. Before launching the live demo in a minute, let me suggest some starting points for further information. So on JMP.com, check our software products to learn more about JMP. I go here, more about JMP, JMP Clinical, JMP Genomics, and also JMP Pro, which comes with all academic site licenses. So here you see some JMP Pro use cases, and you can also check out the exclusive features of JMP Pro. Under JMP in action, you see the application areas, use cases. How is JMP used? And for all of them, including DOE, statistical modeling, and so on, for all of them, you can check out white papers, interesting use cases, and demo videos. At the same place, at Customer Stories, check our customer stories to get ideas how JMP is used in industry and in academia. You will see many reasons why JMP skills really matter for your students. And on our landing page, jmp.com/academic, at why use JMP, you will find some very nice and engaging 60-second videos telling you why JMP is preferred by so many academics worldwide. So now let us jump into the first example. And by the way, on the left of my screen you see a JMP journal, a container for notes, JMP scripts, or other content for a presentation, or for collecting your analysis results. And all academic site licenses give you access to the latest version of JMP Pro for Windows and Mac. On my Mac, I use Jump Pro version 13, launched a year ago, and I run the latest maintenance release, which is version 13.2. The Jump Starter on the Mac, on the Windows menu, on Windows on the View menu, the Jump Starter shows you a more informative menu, especially structured for new users. So this menu gives you easy access to core Jump functionality. So you can choose by category. So here we have the table tools. And you can also see the Jump Pro specific platforms like generalized regression and the Pro features, including more complex neural networks or bootstrapping and simulation. Now, lay back and enjoy the demo, and our follow-up email will give you access to a Jump trial license and to this journal so that you can explore everything on your own later on. Okay, what is
Volker? And if I could just quickly mention that if you have any questions during the course of the webcast, please use the Q&A panel and submit those. We'll get to those questions at the end of Volker's presentation.
Right. Thanks, Kurt. And what I did before the announcement was I clicked this button here on my journal, and this opened a sample data set. So welcome to our big class families, one of the 500 sample data sets in Jump. So here we have family data in 12 variables or columns for 40 kids of a school class listed in 40 rows. And as soon as the data is ready in Jump, you choose the type of analysis, typically on the Analysis, Analyze menu, or a graph type like bubble plots or scatter plots on the Graph menu. So let me show you a first example for an output. So from the Analyze menu, I choose the distribution platform, which is, as you see on the tooltip, for univariate statistics. Next, you assign your variables to roles they should play in this analysis. So these are all Ys and columns I would like to see the distributions for. And the next step is action, go. Okay, so this is the distribution output we got. And we see bar charts for our categorical variables, name, age, and sex. And we get histograms for the continuous data, height, and weight. In Jump, everything is linked. So that means I can choose the kids with higher weight, and we see who they are. We see the names on the name bar chart, and we also see some other information. So maybe interesting, if I choose just the top heights, we see that there are some 12 years old, but no 13 years old in this group. Yeah, if you are interested just in the 12 years old kids, select the bar and double click, and you get a subset of data just with the 12 years old kids from that class. The red triangles or hotspots are your best friends in Jump. So if we look at age, so I can open the red triangle on that variable and then, for instance, add the counts here. Yeah, or I can add a mosaic plot to that output. So that's quite easy, and you see red triangles all over the place. And on the left, so here we see Robert, and this class actually has 2 Roberts. So I can select them, and we see there's one 12 and one 15 years old Robert in this class. Maybe there's no other interesting information here, so let me remove the name information. A top hotspot allows me to stack the variables, the outputs, and change the layout. So if you're more used to horizontal histograms, so that's maybe your preference. And I would like to dig deeper into the weight variable. So here we see the histogram and we see the outlier box plot, and there's one outlier here. So who's this guy? That's Lawrence. And if you're interested in normality for these data, I go to that hotspot and choose, for instance, the normal quantile plot. And this doesn't give us any evidence to doubt about the normality of these data. And choosing it again, I switch it off. It works like a toggle switch. Another option to look into normality is to fit a continuous distribution. So I choose the normal distribution, and the distribution is fitted to the histogram, and we also see information about the fitting. So here we see the fitted normal. There's another red triangle, and there I can ask for the goodness of this fit. And in this case, JMP uses a statistical test. In this case, a Shapiro-Wilk W test. And here you see the test statistic, and that's a p-value in JMP, probability lower than test statistic. And here you see some basics. So the null is that the data is from a normal distribution, and the p-value is not small enough to have some doubt about that. So same result, basically. Okay, let me close this output and look at the number 1 platform on the graph menu. So that's the GraphBuilder, an interactive graphing tool where you can drag and drop your variables from the left. So for instance, if I want to see weight versus height, I drag and drop them. I can switch to a line to see a linear relationship here. And then I can also group this by male and female by dropping the sex variable maybe here as an overlay variable, and then we see that the relationship is different. Again, who is this blue guy? It's a male, so this is Lawrence again. Let me start over. So now I take weight again as my y variable, but now I look into the age groups. So I use age, the categorical variable, on the x-axis. So now we see the values jittered a bit, but by group. And maybe it's a good idea to switch to box plots to see the distributions by age group. Yeah, you can also look at a contour plot if you prefer that one, or a violin plot, and I can also get the data back here. Again, I can choose sex, maybe to overlay or to color the data points. And don't forget, everything is dynamic, so you can multi-select by selecting female or male on the legend, or just by selecting all 15 years old by a multi-select. That's the GraphBuilder, which is also very nice to explore new data sets. And what if you have a variable like this? So here the modeling type, this icon tells you it's not categorical, not continuous. This is unstructured text. Yeah, so what can we do for unstructured text like broken arm or headaches? So these are illness reports we have on the data table as well. So there's a nice way to explore text data in JMP using the Text Explorer, also on the Analyze menu. And this shows us all the terms, basically words, in this corpus or in these reports or documents. And we also see the combined words or phrases. And the top ones are upset, stomach, and knee pain. Yeah, and then you can look deeper into the text data. You can also visualize a word cloud. And here we see for stomach, so what happened there. So you see the context information for stomach problems. And there's also foods used much less. But we can also see, what about foods? And then you see, oh, that was a stomach problem as well after eating fried foods. And the story continues. So there are also options to analyze text data. So this works similar to principal components for continuous data. So we get a two-dimensional space for our terms, for instance, and then if you look at the terms we got here, you see, oh, that's maybe the stomach corner. So we have all the terms which relate to stomach problems, and then you can do semantic analysis and topic analysis and cluster the documents. And that's especially useful if you have hundreds or thousands of documents. Okay, so let me move on to some basics and basic navigation. I keep the same data set open. So I would like to mention the home window you get on the Mac and under Windows. And this gives you access to the recently used files, to all the open windows and reports and data sets. So that's a very handy navigation console, especially if you work on multiple data sets. The menu is shown on top because I'm using a Mac. And here you see the menu from left to right to get data into JMP, DOE, Analyze, Graph. And the menu can also be customized, so you can move commands or just remove submenus if you don't need them. What's maybe more important is that both rows and columns can have states. Yeah, and maybe let's look at some row states first. So let me unselect that one. Some row states. So from my 40 rows, I want to select row selection. I want to select the kids which a height greater than 66. I click OK. And now you see that there are 6 rows selected. And these are the kids with a height greater than 66. So now I have 6 selected. I can go back to the row menu and then I can choose to hide them. And then I get a mask symbol on that row, and that tells me these data points won't be shown, so they won't be used in any graph or visual output. A second state is called exclude, no parking symbol here. And this tells me that these data points won't be used in any calculation or analysis. And if you have both, like right now, so then these 6 kids won't be used at all. So, but they are still in the data set, and if you select it again, so they will be back in your data set. Also, columns can have states. Yeah, so if I right click on the name column, you see there's a label state which is already chosen for the name. So that means if a data point is shown and selected, you will see the name information for that data point. Yeah, I can also right click on age, for instance, and then the most important settings on columns are also shown in the column info window, and these are the types, the data types. So data type is basically how to show some values as numeric data or character data, basically, and the modeling type defines the scaling of your data. So that can be categorical, ordinal, or nominal. And if the data type is numeric, then the modeling type can also be continuous. So these are important settings, and they are also shown left of every variable. So green means ordinal, red nominal, and blue stands for continuous data. Yeah, there are more settings here, column properties like value colors and specification limits, units, nodes, formulas. So these are metadata which can be added to your columns as well. Regarding interactivity, we already saw the red triangles. So that's one of the top 3 takeaways from this session, maybe, if you're a new JMP user. So try out all the red triangles, especially if you use a new platform. Check the options on the red triangles, the context menus. So most sample data sets come with stored scripts. So here I can run this fit weight to age and height script, and then we get this output here. And I just want to show you some additional commands on the red triangles. So open a red triangle, and then if you're interested in effect summary, you can add it by the red triangle. Now, if you're interested in diagnostics, so you can add a plot about the residual by predicted data, and then you get the output added down here. Red triangles. A second way to interact with JMP reports is a hidden feature, the right mouse button. So you can use the right mouse everywhere, so maybe on the plot here to change the background color or other colors or line types. But you can also right click on tables like parameter estimates. I can right click and then I can add a column maybe to see the variance inflation factors. So you can add more information if you don't see it yet. I can right click and sort by p-value, and then this table is sorted. If you want to analyze the data further or visualize it, you can also right click and then make this report table into a JMP table and then go from there. That's the right click, and then last but not least, everything is connected. So that's another hidden feature, but you will love it very soon. Don't be shy and multi-select data, and then you will see that they are all connected. And if I also unselect on the data table, you see this selection goes down to the data tables as well. Okay, so let's say goodbye to our big class families and move on to the next section about data import. And first, if you just want to play a bit with JMP and try it out, you get maybe almost 500 sample data sets on the help menu under sample data. Yeah, and if you're interested in multivariate analysis, check these out. If you're interested in medical studies, maybe go here. And there are also some nice examples for teaching. So if you open a data set, you typically find a stored script you can run by the green triangle. So click there, and this is wind data in the US over time. And this can be shown by an animated bubble plot. I can make the bubble a bit bigger and jump forward in time and increase the speed. And then you see this is Dennis in 1981, and this is Emily and Floyd and Gert. So some hurricanes visualized using an interactive bubble plot. There are even interactive modules in the sample data. So if you choose teaching scripts, interactive teaching modules, and look, for instance, at confidence intervals for a population mean. So if you teach that concept, you can use this as a demo tool or as a tool for students to experience the concept themselves. So here we see that the true mean in the population is 0. So here we have the true mean of 0. And if you draw 100 samples and animate the output, I can start the drawing. So you see all the samples of size 25. And then you see the confidence intervals for the mean. And if the true mean is not included, so then the interval is shown in red. And then down here you see the percentage in green, which can then be compared to the confidence level you can set here. And typically it's very similar or even the same like on this run. So there are more teaching modules covering other concepts, including regression, ANOVA, and they're really great in teaching. Another option is on the File menu, File, Open, and then you can open any data set, different formats, and here you see the formats in the documentation which are supported by JMP, so you can open a lot of different types of data sets, or you start from scratch. So if you're in JMP, File, New data table. And this gives you a green field, an empty data table, and now you can start to enter your data. So if you have data in Excel already, so this is an Excel spreadsheet, so then you can also select and copy the Excel data, and then in JMP take an empty table, and then there's a trick. The trick is not just paste, but paste with column names, and this maintains the header information as column names. It also does a best guess here, so for modeling types, which is typically pretty good. So that's a copy paste from Excel. There's also an import wizard for Excel spreadsheets, but also for text files, which guides you through a process and a preview with many options. And then if you are happy, you click import, and then the data will be imported into JMP. More options to build a query builder tool, a SQL query without programming SQL. So that's also very handy in JMP, and you can also add prompts. You can get data from a SAS server, including sampling big data sets. So many ways to get data into JMP, especially for teaching. There's an interesting option called Internet Open. And if you want to grab data from an internet page, like this Wikipedia page about world population, so if I scroll down, we see that there is a table called 10 most populous countries. And you see a ranking, 1, 2, 3, and so on. We see a flag and we see the population values. If you want to get this table into JMP, you copy the URL and then you choose File, Internet Open. Paste the URL and click OK. Now JMP parses the HTML page and shows all the table data which could be imported. And then you pick the interesting one and confirm with OK. And here you go. So now to visualize the data, you can click on the load picture script, which is added automatically to add the flag images, the pictures. And we have the country names in here, so we have to split this column maybe. So for that I change the data type to character and the modeling type to nominal. Now I can split the strings quite easily using a utility from the columns menu, transform the text into columns. Delimiter is the quote symbol, and we are done. So now you can browse what we got, and this seems to include the country names, this column. There were some footnotes on 2 countries, so I just removed, and now we are ready. So go to GraphBuilder, and the country names were in here, and I take the population for visualization, and we are done. And maybe you want to change the gradient. That's a right mouse click again. I change it to white to blue, and ready. So now we see top population in the world. So here we have China, and that's, who is this? So in this case, a good idea is to use the label state. Right, so I take the picture, the flag, and use this for labeling the data. So now if I point to a country, we also see the pictures as labeling information. So here we have Brazil. That's Internet Open. Quite easy to get web page data, HTML data into JMP. Okay, next is to look at some basic platforms for summarizing and graphing data. And here I use another sample data set, and this is worlddemographics.jmp.jump. And here we have the country names, and for all the countries, in this case 239 countries, we have a lot of information, including the population, death and birth rates. We have mortality rates and rankings. So that's all given by this sample data set. So if you start with a new data table, maybe a good idea is to check the columns using the columns viewer. So I take this one here, and then I select the variables I want to check in an overview, and then I click summary. And now we got a nice overview about categorical variables, which are shown with their number of categories. Yeah, and continuous data is shown with some basic statistics, so minimum, maximum, the mean, standard deviation, and some others. Yeah, and you also see the number of missing values for both of them, both types. Yeah, and here this is the GDP in $1,000,000. And we see, oh, that's a really huge maximum we didn't expect. So which country could this be? Okay, so if you select it here, you can directly open the distribution output from there. and we see the maximum here, and when we point to that data point, we see, oh, that's the world. It's not a country, it's the sum of all the countries. Yeah, and then you can select it and choose to hide and exclude this data point. So forget about this one for the next time. And if I redo the same analysis, so we get the same report again, but you see the scaling is different. And now we see the real countries with high GDPs, and guess who they are? So the first one are the United States, and the second place goes to China. So let me close that here. So that's called the column viewer, and this gives you a nice first check about the health of your variables and ranges and so on. To create summary tables with numeric information, basically, you can use the Tabulate drag and drop tool. So here we see the workspace, and now again you select your variables. So I choose the infant mortality rate and the 5-year mortality rate, and then I drop them here, and then we see a default statistic for these two variables, which is the sum. But I'm not interested in the sum, I'm more interested in mean and standard deviation. So I replace sum by these two statistics. Next, I want to break this down by development level. So the countries are sorted by development level from low to high. There are 4 different levels, and I can break the table data down by using this as a grouping variable. If I want to change the format, so that can be easily done here. So use the same fixed decimal with just 2 decimals, and then it's a better output maybe. So that's good enough. And when you're done, you click done. And this is basically a table with numbers. Yeah, you can add a chart, and you see that both mortality rates go down when the development level goes up. So you can see it may be easier when you look at the visual output, but this is typically a tool to create tables with summary statistics. One generic feature at this point, if you want to store something and keep it in JMP for later use, or if you want to share it with other JMP users, a nice way to do so is on the red triangle, choose Save Script, and then save this as a script, maybe to the data table. And then I can specify a name here, my Tabulate, and I can close it, and then in a week I can open the same data table again, and then I will find this script, and then I can rerun it, and I get back to the same point, and now I can reopen the control panel and add other information and change it. Okay, so that's Tabulate for summary tables. The big brother of Tabulate is GraphBuilder, another drag and drop tool, but this is to create visual output, to see relationships visually using different graph types for a certain number of variables. So let me show you an example. So I take the crude death rate and use this as my y. So I drop it on the y-axis. And I want to see it by crude birth rate, which I drop on the x-axis. And we see this. I can change the smoother to a line and break this down by development level to see if this relationship depends on development level. And I can drop the grouping variable here or just overlay Maybe if you want to see them separately, you wrap by development level. If you want to maybe easier compare the relationships, you use them as an overlay variable. And then it's very evident that the relationships are dependent on the development level. Start over. So what's next? So I can also use the same y variable, but now I use the development level on the x-axis. So that splits the data into 4 groups, the different levels. I can also add another variable. So if you also want to see the birth rate, I can add that one here, and maybe, so we are looking at group data, so I can switch to box plots, and that's maybe a nice way to look at the data. And we see that the birth rate goes down, the median at least, and the average if the development level goes up. Okay, start over. So the territory can be again used to activate the shape files. And now I can again put the population in here. And if you see the population by country, I would like to change the color again. Maybe you agree that white to blue is a better choice in this case, and maybe we are done. But what if you want to look at other variables instead of population, but by country again? So you can take any graph as a template. You did already. Let me choose done. So this was done. And then I can use the column switcher to replace population by a set of other variables. And now I can walk through these variables, and we see them by country. And you can see if you find anything interesting. So maybe here we see the male-female rate under 15. So there's a country which really steps out, which is China in this case. And you can also see the value for China if you point to the country. Let me remove the column switcher, because there's another tool you can also add to most JMP platforms, like the column switcher, which is generic. The other generic tool is a local data filter. So they can also both be combined. So you get a lot of flexibility here. But if you want to look at a subset of data, so I can use the column, the data filter, and then for filtering, I choose the overall life expectancy at birth. I choose this as a filter variable, and now because this is continuous, I get a slider. And you see if we only look at the high life expectancy countries, we see that Africa is almost gone, except the northern states in Africa. And if you look at the other end, you see that this is a lot about African countries. So that's the data filter. Okay, some tips, especially if you are a new user. So what I would suggest to keep in mind, first, of course, the red triangles, and I think I already showed you some examples how to use them. So here, for instance, we have one variable which has a plus. That means that this GDP per capita variable has a formula. So it's not with static values, but it has a formula. And there's also a distribution script which shows the distribution for that variable with a formula. And you can check the red triangles again to add a cumulative density plot and to add summary statistics here. So if you want to see other summary statistics, in this case, just add them locally. If you want to make them your defaults, if you want to see them by default with any distribution output, go to the Preferences and then Platforms, Distribution, Summary Statistics, and there you can add all the summary statistics you would like to see as default output. So that's the preferences, also a nice way to check out, and there you can also change the language of JMP on a Windows computer. For Mac it's slightly different, but you can change also the JMP language to many other languages. There's one script here which is a hierarchical cluster analysis. So let me open that one. So how to get high quality images, maybe for a paper or for a presentation. So there are two tricks. The first trick is from the Tools menu, choose the selection tool, or just press S on your keyboard, you get the Fat plus. Then you can choose what you want to copy. Maybe I just want to get the dendrogram from this analysis. You copy it. And then, for instance, in Word, an empty document, don't paste, but choose Paste Special. And on a Mac, it's PDF. On Windows, it's Enhanced Meta File. And then you get a high quality image, a vector image, which can be resized, and you keep and maintain the highest quality. Yeah, if you don't know what is this, a dendrogram, you can also use the help tool and then, or press the question mark, drop it on something what you're interested in, like the dendrogram. Yeah, and then you get context-sensitive help, and the help explains you what this is about, in this case, the dendrogram. Yeah, and if you want to create a dendrogram and you don't know where to find it, so I also suggest to check the statistics index on the help menu. So if you go to dendrogram, and there is an example, you can open the help or just run an example and see which platform uses that method. So if you're interested in a statistical method, check the statistics index. Okay, we have a few minutes left to show you some basic analyses using my last sample data set. So this is car physical data, and this has data about 116 cars. We are mainly interested in horsepower of a car, and the question, can we predict the horsepower when we know about the weight, the turning circle, gas tank size, country type, some other information about a car. Now, so again, this is a new data set, so it's always a good idea to use distribution. I just take all the variables in here, and then you can check them. I choose the cars with high horsepower, and then I see if there are any other interesting relationships. So we see that high horsepower cars come from all the countries we have here, but these are not the small cars, of course, but it's easy to see these relationships, and average weight is quite high for these cars. By the way, if you want to run a statistical test, red triangle, so here you can test for a mean. I specify a hypothesized mean, 3060. There's also an option for non-parametric tests in many places in the same context, and then I just click OK, and then JMP does a t-test, and you see the test statistic, and we also see the sample distribution for the mean, if this is the hypothesized mean, the real mean, and here we see the red marker, which is the observed mean in our data. And this is quite unlikely to observe such a mean, so you also see that the p-value is quite low and it's in red, and this tells you that this is significant. This is just about testing, which can be found in the right context. You find the right method and test, and JMP suggests the tests which make sense in a certain context depending on the types of your variables, the sample size, and some other information. Next step, bivariate analysis. Let me also show you that one, or at least give you an idea. So that's the next command, fit y by x. So 1y, 1x. As I said, we are interested in horsepower, and the other continuous variable is displacement. So that's a continuous by continuous relationship. But I also want to see the relationship between horsepower and type. And that's a continuous categorical relationship which will lead to a one-way ANOVA analysis. So I can click on OK, and here you see the two cases. It's the same platform, one platform, fit y by x. On the left we have continuous by continuous. So here I can, for instance, fit a line. Yeah, we can also add a density ellipse. So that's the bivariate normal ellipse. And down here we see the correlation coefficient. So that's about the continuous case. It's a lot about fitting. On the other side, this is continuous by categorical. Type is categorical. So you get other options. So here you can ask for means and ANOVA. And the ANOVA table tells you, hey, this is significant. So there are some differences between our groups concerning the group means. There are some differences. So where are they? And then red triangle, compare means. You can choose just a pairwise student t-test. And the color tells you about the difference. If colors are different, the means are significantly different. And this does multiple comparisons. So if you want to choose another way, maybe the Tukey honest significant difference test, which is a better choice in case of multiple comparisons, you get other circles. Circles are bigger, so that means this test has less power than the student's t-test, but you get to the same conclusions. And just for completeness, very briefly, so the other two cases of this platform, if we take type as the response and look at the relationship with horsepower and with country, so from the same platform you can also get a logistic regression output on the left, categorical versus continuous, and if both variables are categorical, you get a mosaic plot and a contingency table, and of course all the tests which make sense and methods to dig deeper on the red triangle. And finally, multivariate, the multivariate case. So here I choose fit model, and then I want to predict horsepower. So this is the model building platform, a very generic one with many options, including mixed models, generalized regression, and more. So let us just use standard least squares in this case. And as model effects, I choose all the information we have as main effects, but not horsepower, of course. That's my Y. And I run the model. But wait, if we maybe learned from the GraphBuilder that this relationship here, horsepower by displacement, that this relationship depends on a third variable, namely country. So if you saw that during the exploration earlier, then it's maybe a good idea to add the country displacement interaction to our model terms and build the model. Yeah, so here we see the actual versus predicted plot, which looks quite good, an R squared of 82%. And here we see the most important predictor is displacement. The least important is weight. So let's forget about weight. I select it and remove it interactively. Also, gas tank size is not significant. So I can remove it from the model, and all the other output is updated immediately. Yeah, you can look at the outputs and the estimated parameters, but the best way to learn about the relationships and how the model works is by looking at a visual tool called the profiler in JMP. And this is the profiler, so we still have 4 effects in our model. Yeah, and here we see that these are just linear relationships. Yeah, so it's a simple model. Displacement is more important, it's more significant. We have a steeper curve. Yeah, and you can ask what if, and you can change one factor, and you see how this influences the predicted horsepower on the left. So for this type of car with the red settings, yeah, you get a horsepower of 223 as predicted by our model. Yeah, and we also see an interaction here between displacement and country. So for low displacement, US have the highest horsepower. For high displacement cars, US cars have the lowest horsepower. So interesting findings you can immediately get from the profiler. And then you go typically further. You can also optimize using the profiler if you have some goals set. But you can also deploy your model in different ways. So here using the formula depot, I can deploy it as C code, Python code, JavaScript. Or you store the prediction formula to the data table. And now we have this added to our data table. So here is our predicted formula for horsepower. You click on the plus and there you see the formula for this output. Okay, so that was my last example. Just to wrap up, we will send you an email, and this gives you access to download the journal, but you will also get access to learning resources and resources you can use in teaching. And you will get all these links here, and the central link is our resources portal at jump.com/teach, where you can also find other webcasts, but also course materials and also e-learning courses, which are included for free in our academic site licenses. You can get trainer kits and training material for many topics. If you want to build a new course using JMP, you get great examples and demos. And the course collections, that's our best of for certain course types. You get a selection of the best one-page guides from the learning library, cases, add-ins, and books and webinars, which are really helpful for these type of courses.